Hello viewers and welcome to Maths 24. My name is Fritz and this lesson is on solving quadratic equations by the graphical method. Solving quadratic equations by the graphical method. Let us take the first example. Solve the equation x squared minus 4x plus 3 for x ranging from 0 to 4. The first step is to make a table of values for x and y. And for the x, the values are from 0 to 4. So I have 0, 1, 2, 3, and 4. The second thing to do is to copy out the function term by term on the table. In this case, the first term, there is x squared. I'll copy it out. The next one is minus 4x. And the last one is a constant term, plus 3. Let y be the function y to be equal to x squared minus 4x plus 3. Thus, we will have y to be occupying that position. The next thing you have to do now is to take each value and simplify by column. So for the first one, you have 0 squared is 0, 1 squared is 1, 2 squared is 4, 3 squared is 9, and 4 squared is 16. Next, we take the next value, each of the x values, and multiply by minus 4. So minus 4 times 0 is 0, minus 4 times 1 is minus 4, times 2 minus 8 times 3 minus 12, and times 4 minus 16. The last term is a constant term, so we just add it all through on the table. Finally, to obtain the values of y, sum the values in blue. Quotient, sum just the values of y in blue. And this gives us 3, 0, minus 1, 0, 3. Some grade 9 and 10 students usually make this mistake and sum everything. You must avoid this type of error. The second step is to plot the values of x and y. And looking at what we have here, we need to choose a good scale. For the x values which lie between 0 and 4, so I will make the x-axis to range from, say, minus 2 to 6. Above the scale a bit, or above the values that have been given in the equation a bit. For the y-axis, 0 to 3 will have a larger space compared to 0 to minus 1, since it ranges from minus 1 to 3. So that's the scale we have on our graph here, and the next thing will be to start fitting in these values. The first thing is when x equals 0 on the table, y equals 3. So we plot the point 0, 3, as you can see the star blinking. The next point is when x equals 1, y equals 0. We have the second point, as you can see the star blinking as well. The third point, x equals 2, y equals minus 1. We have that point. And when x is equal to 3, y is equal to 0, and we have that point as well. The last point is when x equals 4 and y equals 3. Now we have all the points. We just link all these points with a smooth curve. Do not use a ruler to link the points. Use a smooth curve. And when you use a smooth curve, this is what we are going to obtain. You can see the smooth curve. This curve has a valley shape, so it has a minimum value. The points where the curve cuts the x-axis gives us the roots of the equations as, so we have x equals 1 and x equals 3 being the roots of this quadratic equation. Next, let us take another example. You have the equation x squared minus x minus 2 for x ranging from minus 2 to 3. So the first thing to do equally is to make a table of values for x and y from minus 2 to 3 for the x values, and we copy the function term by term on the table, x squared minus x minus 2, and we have y to be equal to the sum of those values. We now take each of them and square them. We now multiply each of them by minus 1, and we copy out the constant term. To obtain y, just add all the terms in blue, and we have those values. The second step will be to plot the values of x and y on the coordinate axis. After choosing a suitable scale from minus 2 to 3 for x and 0 to 4, having a larger space for the y, we will have when x is minus 2, y should be equal to 4. When x is equal to minus 1, we have 0 for y. When x is 0, y is equal to minus 2. And when x is equal to 1, y is equal to minus 2. And for the last point, we have the points 3 and 4. We now use a smooth curve to link all of these points, and we have this curve as shown here. So the values of this equation, or the roots of this equation, are x equals minus 1 and x equals 2. Thank you so much, and don't forget to subscribe and click on notifications for more is still to come. Bye bye.